Hello everyone, welcome back to my channel. I'm Dr.K.Mouthami, Assistant Professor from KPR from Coimbatore. So in today's session, I'm going to explore an important concept from data structure. So the data structure implementation stack is implementation using array. Okay, and the stack is a simple logical container that helps us the managing the data efficiently using the last in. So let's see the next slide. So let's talk about the concept of stack. You may imagine stack as a kind of container or bucket that's open only at one end. Okay, already you know that. So we can only add or removing things from that inside. Okay, not both side, not or this and that. So only you have to follow last in start up. So that's why it follows a very specific order last in first. So or otherwise called as leaf. Okay. So think of stack of plates in canteen. So it is a first example. To always put a new plate on top of it. So it is a human behavior. Okay. So likewise, when you need one, you take on the top plate first. Okay, you never pull on the bottom page. So this is the best example of stack. One example is the undo button. When typing the last thing you type or changed is the first thing that gets undo. Okay, and the last real-time example is even your web browser uses a stack. When you click the back button, you go to the last page you missed. Okay, so this is what this stack. Okay, and now let's see how we can actually implementing this stack. Okay, so there is two implementation, array implementation and linked list implementation. So this session we implementing through array. Okay, stack implementation by using array. One of the simplest way is by using array. So we fix this fixed size array to store the elements of stack. So that's mean we decide in advance how many items our stack can hold. So for example, here it's defined as size 100 means. So the stack can store up to 100 elements. Or otherwise we can call it as 0 to 95. N minus 1 we can store. Okay. We also have a variable called the top. So the top variable it keeps the track of the index of the topmost element tab. Okay. So top element variable it is very useful. Why? Because we can storing the we can point out the topmost element. So initially top is set to be -1. Okay. So this code I will into top equal to -1. Like this you have to write a, so that indicate the top of the stack. That is -1 means which means the stack is empty. So we declare something like this. So this means if the stack is the container where all our elements will go. Now tell us where the last inserted element. So I will describe the main operations in the stack. Now a stack mainly has two key operations. The main operation function. Okay. Now, to add an element to the top of the stack. Before choosing, we check if the stack is full. If top equal to minus size -1. So if no means we increasing the top by 1, top plus 1. Okay. And place the new element there. Okay. Are you clear? This is what the pop operation. Sorry, this is what your push operation. Next we'll explain pop operations. So to review the top element before popping, we can check if the stack is empty, if top equal to minus. Okay. If not means we can take out the element at the stack of top and decreasing by 1. Top by 1. So top minus minus you can give. Okay. So next we can use in the push operation. So now that understanding and how the push operations works in the stack implementation using array. Now the word push uh, means you can add new element on the top. Okay. So before we adding anything, we always need to check whether the stack is already full or not. Okay. In array based stack, this happens when top equal to my size minus 1. Because that means all array positions are already filled. Okay. And I got my point. Okay. If the stack is not full means, okay, some what they have a space means, then we can have a safely added new element. Okay. So first thing is we increasing the top value one by one. So that's why I'm incrementing the top list plus. You can see this code. Okay. So then we start the new element at the position. So the stack of top equal to value. Okay, which is mean that we can adding the new element at the position. But if the stack is already full and we still try to add another element means we get the situations, okay, called stack overflow. Okay, already filled means the stack is overflow. It means we have gone beyond the storage. Okay, overflow. Okay, gone beyond the storage limit of our stack. Okay, so let's break it down to the this kind of example means. So if the condition is checked, if the stack is full, if it is not full, the top moves one step up and we can assign in the new value that. So finally we print the messages confirming that element was added successfully. Okay. So I will give real time example. So you have more clear about that those operations. So imagine a stack. Again, I'm telling the example. Play it again. So if a rack is full, you cannot add anything, any other plate here. Okay, over here. So that's overflow thing. But if there is a space, you place a new plate on the top. That's exactly what push does here. Okay. So that is what the okay. And then pop operations. Now that's we have seen how to add an element using pop operations. So let's look at how we removing that. So it is called as pop operations. The pop operation means taking out the topmost element from the stack, just like removing the top plate from your rack. Okay. Before removing anything, we must check the stack is empty or not. Okay. If it is empty, if top equal to minus 1. So that is what the first condition. You see this code. Okay. If it is empty, there is anything to remove. And that situation is called as stack underflow. In push operation, you may check stack overflow. Op operation means you may check stack underflow. Okay. If the stack is not empty, we follow these steps. Okay. What is the step? First, we take the element from the stack of top and store it in the temporary variable. Okay. Then we reduce the top value one by one, top minus means. So which means that the stack now has one less than element. Finally, we can display or return the pop element. So if the stack is empty, it brings stack one under. Otherwise, it prints the top element and decrease the top pointer. Okay. So this is what the pop. Okay. Before push check whether the stack overflow means is no more space to add. But pop check the stack underflow. So underflow means nothing left to remove. Okay. think about the stack of plate again. If you try to remove a plate when the stack is already empty, that's underflow. Okay. So pop means take the top one out, and but only if there's something is there is. Okay. So that is what your pop operations. Next, after understanding your pop and push operations, there is one more very useful operations is that it is called the peak operations. The peak simply means looks like at the top element of the stack without actually removing it. So it is like changing which plate is on the top of the track, okay, without taking it out. Only you will displaying the what is the top of every element. Okay. Before taking, we first check if the stack is empty or not. Then only we can display the top. So we can check the top equal to -1. So if it is, if not empty means we can safely look at the top of element at the top. Okay. And displaying those elements. It is importantly we don't change the top value because we are not removing anything. So if the stack is empty means we get the message. Otherwise, it just print the current top element. Okay, you see this code. Okay, and move on to helper functions. There is two helper function, is empty and is full. Okay, now apart from the push and pop operations and peak, we often use two helper function, is empty and is full, to make our code clear. Okay, is empty function is simply check whether the stack has any element. If top equal to -1, it returns true, means the stack is empty. So before doing a pop or peek, we can call is empty function. We ensure stack is not empty. Okay, so this is what your is empty. Next we'll expand is full. So similarly is full to check whether the stack is reached the maximum size if top equal to size. It means stack is full. Okay. So we may say that, so before doing a push, we can call is full function to make sure there is a space is available or not. Okay. After that we will push. Okay. And before I conclude, let me give a quick summary of what we have discussed today's session. That is abstract data type, that is called as ADT, that follows the last in first one. Okay, working here. Meaning that the last element we add is the first one to come out the first. We implementing the stack using an array and we use a variable called top. So, which is to keep track of the last inserted elements. So then we saw the four important operation. Push to inserting an element, pop it is used to removing the element, and pick it is used to just view the top of the element without removing it. Okay, and use simple and useful. So to check whether the stack has space or not. Okay, by using these functions. So overall, the stack is simple but very powerful structure using programming language, from the managing functions to handling undo operations and even browsing history. So that's all about the stack implementation using array. Thank you everyone for listening my presentation. I hope this session help you clearly understand how a stack is working. If you have any questions or wants to me to explain any part again, please share your thoughts in the comment section. And if you this helpful video means don't forget to like and subscribe for more such sessions.